Exactly. I mean, the chicken had to have come first. Oh, hi! So, today we're going to be talking about coastal transportation and coastal erosion processes. Transportation, the movement along the coast of material. Erosion, the wearing away and removal of material. Let's get going with transportation processes. Okay, so there are four main methods of transportation of material at the coastline, and the method that is in operation depends upon the energy of the water and the size of the material. So here we have the bedrock or the surface underneath the water, and this is our water column. Now at the coast, the water is being moved by waves, which are generally moving material backwards and forwards all the time. The largest material, which is heavy and would take a great deal of energy to lift up, that is rolled along the bottom, like a big wheel turning. And this process of transportation is called traction. It's the first of four processes. As these materials get a little bit smaller, the energy in the water is able to periodically pick up that material and bounce it along the seabed. And in this way, material is transported along. This bouncing motion is referred to as our second process, which is saltation. Material getting smaller still, so that we move to kind of more sand and silt sized particles, which we can see here. Then there is enough energy in the water for that material to be carried permanently in the water column. So not rolling or bouncing along the bottom, just held in the water. And this process is called suspension, where the material is suspended in the water. The final process of transportation, difficult to draw because you can't see it, is where materials get dissolved in the water. So especially if the water has a slight pH or the material is limestone, then they dissolve and are transported in solution. So the ions are dissolved into the water. And those are our four processes of transportation that we will find operating at the coast. They do also operate in rivers, so this is a nice double up of revision. Let's have some questions. When is material rolled along the bottom? Good. When it is large material, or you could also have said when there is a lower energy in the water. And what is that process called when material is transported by rolling it along the bed? Correct, well done, that's traction. As the energy increases, which process of erosion of transportation is likely to follow traction? That's right, saltation. And what is saltation? Describe it to me. Good, it's the bouncing of material along the seabed. What is the name of the process where material is dissolved into the water so that you can no longer see it? Excellent, that is solution. And finally, when small material is held within the water column, this is called suspension. Nice and easy. what kind of materials might we expect to be carried by suspension? Good. Sands and silts, maybe. In the coastal area, where is the majority of the movement of the water generated from? What is moving the material? That's right, it's the wave action, which goes forwards and backwards and forwards and backwards. So now what we're going to do is have a look at how transportation is linked to erosion processes that happen at the coast. Let's get on. Okay, so let's look at processes of erosion that we will find at the coastline. The important thing to remember is that there are 5 processes of erosion. The first one we're going to talk about is when you have larger angular rocks that are colliding with each other. Now that might be because the waves are moving them forwards and backwards so that these stones are constantly colliding with one another. And as they do, the angular bits, the sharp bits, are going to get knocked off because they're sticking out. And as those angular bits get knocked off, the material becomes smaller and also more rounded. So not as sharp anymore. Those processes continue so that over time the material gets smaller still and more rounded still, and eventually they will become sediment that is suspended in the water or deposited on beaches. This process of erosion is called attrition, and it is the wearing down of material as they collide or through the process of collision. So that is process number 1. Process number 2 is where we might have the seabed with some layers of rock underneath. You can draw in the sea above. And on the seabed we have some of those larger fragments maybe. With the waves passing and moving the material backwards and forwards, this material is rolled over the seabed. We remember the name of that process where material is rolled. It's called traction. As it's rolling away, not only are little bits of the material being chipped off and knocked off, but it is also going to be smoothing the surface of the seabed and eroding any irregularities that are existing, so bumps that stick out. And that means that over time we end up with a much smoother seabed, and with our kind of more smooth and slightly smaller rocky sediment now being rolled around on top of it. And this process is called abrasion. And it's often described as like a sandpaper like action, because you can imagine that if these rocks were the little grains of sand on sandpaper and we rubbed it backwards and forwards over the rough seabed surface, then it becomes smoother. It doesn't have to be huge material like this. It can also be small suspended bits of sand that are also going backwards and forwards and doing the same thing to smooth out the seabed surface. And that is abrasion. Let's have a look at process number 3. Where the sea meets a cliff, often there are lines of weakness in that cliff, cracks or faults. And the waves are going to be pounding into that crack, forcing air and water at great pressure into the crack. And that pressure creates weaknesses, such as this crack or fault, to become weaker still, so that they begin to break down and bits of rock will chip off. The end result is that that crack is widened, with the excess material being carried away by the sea. This process of air and water being forced under high pressure is called hydraulic action. And this is our fourth, no it's not, it's our third type of coastal erosion. You can see this feature here is a cliff, and so often it is where waves are hitting into cliffs that we will get this process of hydraulic action occurring. Also, at cliffs with high energy waves hitting the coastline, we might find that those waves are transporting in suspension small particles or rocks, and as they are thrown against the cliff, this also has the result of weakening that cliff face and speeding up the rate of erosion that we might experience. So this hurling of material, I'm going to write that in, a hurling of material, we call this process corrosion. And our final process of coastal erosion is where we have rocks that are prone to being dissolved. So limestones in particular may dissolve in the water. So the ions are dissolved and the rock becomes smaller, with free floating ions dissolved within the water column, and we call this solution, where material is dissolved in slightly acidic water. Okay, so let's have a look at our 5 different processes. Let's zoom out so you can see them all, and let's have some questions. Which process of erosion involves high pressure being built up in lines of weakness by air and water being forced in? Good, that is hydraulic action. And what is it that is going to be forcing that water into those cracks? That's right, it's the power of the waves. Which process of erosion involves dissolving rock in slightly acidic water? Yes, that's right, it is solution, as you can see at the bottom there. Which process of erosion involves material rolling and scouring in a sandpaper-like action the bedrock, or sorry, the seabed? Yes, that is abrasion. Well done. And what is the process of erosion where angular rocks collide with each other and become smaller and rounder? Very nice. That is indeed attrition. There's one more. Explain to me what corrosion is. Good. Words you needed to have used were in suspension and hurled. So we can say material held in suspension is hurled against a cliff by the waves, weakening and eroding them. Very nice. So you are now going to have a go at answering some of the following questions into your notebooks. Good luck. Okay, welcome back. So the last thing I wanted to look at really is where are these various processes operating at the coastline. And it's important to be able to link them to the landforms that they form. So you'll be familiar with this headland sequence where we have an arch which has developed from a cave where a fault or line of weakness was exploited by erosion to get widened into a cave, eventually eroding through the headland to form an arch. There's the sea, so you can see we're going through. And eventually those arches collapse, leaving a stack standing on its own. So where are the processes of erosion operating? You can see that the material that might have collapsed from our old arch gathers on the seabed and is rolled around across the seabed. Now that is going to have the process of smoothing the layer of rock on the seabed, and this creates a wave-cut platform. So the process of abrasion is going to be very dominant in creating a wave-cut platform. Equally, as those rocks are being rolled around and bumping into each other, they are going to become rounder and smaller by the process of attrition. As they get smaller and can be carried by or transported by saltation or suspension, then the sea or the waves are going to pick them up and hurl them against the stacks and the cliffs, exploiting these lines of weakness, forcing air and water inside, and so hydraulic action is going to dominate, as well as corrosion with the suspended material being hurled against the cliff. So we can see that we've got all four of those processes of erosion operating here. And if the water is slightly acidic, and this is typical in more tropical areas with warmer waters, then the water can also be dissolving this rock here in solution. So where the water line meets the rock, we can get solution as rock is dissolved. But let's travel inland a little bit to our bay, slightly more protected, but the waves are still rolling in, and as they do so, they're going to be pushing material up the beach with the swash and dragging it back down with the backwash. And those stones are going to be grating and rolling over each other constantly. And if you go to the beach, you can hear this kind of and that's just millions of stones being colliding with each other with each rolling wave. So it's not hard to imagine that all the angular bits of those rocks are broken off, and we end up with a very smooth and progressively smaller pebble beach, until eventually it might be a sandy beach. So here we have the process of attrition and traction. So let's have a couple of questions here. What type of erosion is going to be acting on lines of weakness in a headland? Good, hydraulic action. And what type of erosion is going to be forming the wave-cut platform, that kind of nice horizontal, smooth platform around headlands? Yes, abrasion, as that rocky material is rolled backwards and forwards by the waves. And what happens to the sediment that is being rolled backward and forwards by traction? Good, it becomes smaller and smoother. What process is also going to be eroding the headland using the smaller material to throw against the cliff? Very nice, corrosion. Excellent. And what about a beach? What can we be expecting to happen there? Good. So there'll be attrition and there'll be traction, and so the pebbles on the beach will become what over time? Exactly right, smaller and rounder. Very nice. Okay, have a go at this question.